Okay, so guys, we have Vachan and Ganesh with us. Hi, UrbanLadder. We're going to talk about their stack and their journey in Dockerizing their application stack. And I guess we'll start off with a little introduction about what UrbanLadder does and what these guys do at UrbanLadder. So, Vachan.
Oh, hi. So UrbanLadder is basically your normal online e-commerce company. We are mainly into home decor and furniture. And we are majorly, technically speaking, we are majorly a Ruby on Rails platform across the board. And we have literally Go and Python and everything. And we are basically, we handle the DevOps related stuff, anything infra and all. We are the DevOps
And sure.
I'm Ganesh and I'm a DevOps engineer. Since I've spoken most of it.
Okay, cool. So what portion of the application stack, or what portion of the UrbanLadder stack is Dockerized? And I guess before we kind of get into specifics, if you talk about what the backend of UrbanLadder looks like, what the different products are, and then talk about which portion of that is Dockerized, that will be helpful.
So think of it from a very layman perspective. You have a site, then you have various components to handle inventory, then process your order, then handle customer data, and other details. So to begin with, there are two monoliths. One deals with your main website, and the other is the traditional legacy inventory management platform that we have. Then we have 13 microservices. So most of them are like, so the first one, let's say, is search. So any product that you see in UrbanLadder is powered by search. Be it on Google Web, or be it on desktop, be it on apps. So it's powered by search service. Then there is a consumer service that actually holds all your customer related data. Then there is the CRM service that handles all your. We also have a Salesforce integration, so all the Salesforce integration is handled through CRM service. And these are just the three I'm talking about. There are multiple services like these.
Got it.
So the idea is to not make these monoliths bloated. So functionality wise, it's very hard to maintain monoliths, and it's not as fast as to develop microservices and spin them off independently.
Sure. So you're like pulling one feature from the monolith and making it a microservice. So basically, like you pull the search feature, you pull the inventory feature from the legacy monolith.
And which parts of this are Dockerized, or is all of it Dockerized?
The microservice pieces that we have pulled up
Are Dockerized. And the monoliths are not Dockerized.
Monoliths, we have not got into it yet.
Okay, got it. Awesome. So when you were doing this movement to microservices, and you guys decided not to carve out microservices from the legacy monolith, right? But you decided that for the new features that you want, you're going to move to microservices, right? Okay. How did you maybe this is more of a dev question, right? But how do you guys think about, were there any dependencies between your monolith and your microservices, and was there a trade-off there that you guys had to think about, or were the functionalities that you were carving out so neat and so separate that you can build? So
Mostly latter.
Okay.
So of course microservices had dependencies like on data stores and say a queuing system. So most of the microservices are dependent on your queue, that's beanstalk queue.
Right.
And something like search is dependent on Elasticsearch.
Right.
But other than that, there are no hard dependencies on monoliths itself. So my monolith can function just fine without.
So all of these dependencies are captured within these data stores. So that brings us to what are the databases, very stateful services that you guys are running on the stack. So what the primary application database is?
It's MySQL, and it's hosted on RDS. And we also have SQL Server for one of our Windows application.
Okay.
And we also have a MongoDB server for subscriptions and other services. We have Mongo, which is self-hosted, and we have our own self-hosted ES clusters for both to maintain the application data and for the logging
And for Logstash.
the whole CLK stack.
I see. Okay. And for queuing, you said you guys use Beanstalk.
Yeah.
You guys are not exploring things like Kafka, etc. yet, or is that under roadmap?
So Beanstalk was already in place before we
Okay.
And we didn't face any major issue here so far.
Beanstalk works, so it provides the tube namespace for our concept,
Right.
so it works out really well for us. And its workers are also like bundled so closely with rates, so it just works for us.
Cool. So before you guys and how when did you guys do the Dockerization?
It started off since last year.
And before that you had these microservices, but they were not Dockerized.
We did have quite a few of them.
You had a few microservices,
So
but they were not
all the
Dockerized.
DevOps tools were on Docker as fast as they can.
Okay.
But all these business basic services like search, they were Dockerized very easily.
Okay. I see. So what was your what did you have before you had Docker throughout your DevOps stack, and even when your runtimes, your business runtimes are also now on Docker? What did you have before you had Docker?
So we had a chef plus upswap stack. So we didn't want to have a hosted chef server. And at that time, AWS had come up with this really neat upswap setup.
Okay.
So all we had to do is deploy recipes and maybe roll back and set up recipes, and that's it, we were done. So all our monoliths plus microservices were on Chef.
Okay. And so what was the motivation of Dockerizing, or why did you guys want to move to Docker if everything was already working with Chef and you guys got OpsWorks and OpsWorks were also working well? What was the main motivation? Or was it just because it was cool?
No. So there is that aspect somewhere. But then we wanted to, so basically everything was driven to improve the efficiency. It could be operational or cost optimization, everything bundled up. So and Docker was in such a way that it would provide all of it for us, like indirectly or directly. Okay, providing like cost benefits it will provide, because we would be, so to give a fair example, we basically for our microservice and other related pieces we had around 33 instances. So now we've brought it down to 4.
Okay.
That too, one on demand and the other is spot.
But is that something that you could not have done without Docker?
So the operational
Challenge would have been too high. I see. But so was this a planned initiative? Do you guys already know that when you guys were evaluating Docker that when we start using Docker, what is definitely going to happen is that from 33 we're going to come down to 4? Did these benefits?
So these were all evaluated.
What was the mental model that you guys were working in to decide? Okay, it's worth it. Let's go for Docker. I mean, I'm sure that post using Docker, you guys have been able to articulate the benefits far more tangibly.
Correct.
But before that, what was the situation like?
So we didn't have a very concrete plan on how many nodes to run and things like that.
Okay.
We were sure that the number of nodes will come down, but 1 or 2 or 3, that was still in process. It completely depends on how hungry my applications are.
Right.
And other than that, everything else apart from these node metrics are planned. So we had a specific architecture for how Hyper workers are going to be migrated, how my setup is going to look like, how are we going to handle the secrets, how are we going to handle deployments, rollbacks.
But that so all of that planning happened when you said guys I gotta go and do it, right? But again, what I'm trying to understand is, and this is especially important for people who are not on Docker, right? Is what are those facts or observations, or what are those symptoms that you see in an engineering team or in a company that kind of make you feel like, okay, existing tooling is not good enough, I need to move to Docker? What are those symptoms like?
Usually the devs would come to us and say, oh, it's working on my local but not on staging.
But
So
that was a problem.
So they would come and tell, oh, it's improvisation.
Right.
So with Docker that is completely solved, because a dev can just build an image and ship it to staging or dev environment. So we can't. So that was one of the issues that we knew for sure
would be tackled.
Yeah.
So for someone who joins the company, right? Imagine they're spending a full good week on setting up something, right? And most of you have faced this issue at one point or another. Right? You're gonna set up local MySQL, then you're gonna set up local dependencies, then install
it and runtime.
Yeah. Instead, I could write you a nice compose file, and I'll say, bro, do Docker compose up, and you're done.
Everything.
Yeah, I think it's done. Unless you have a very underpowered systems, which is not the case in most companies.
Cool. So So that's nice. But a part of this migration step now, if we get into how you guys are planning out your migration, you were mentioning that you guys thought about configuration management, how you're going to handle secrets, how you're going to handle deployments. You guys planned all of that out before you made the move. You also had to involve the developers, make sure that they are able to dockerize their files. So there was this round of like, what was the?
So in this case, the developer involvement was pretty limited because for microservices, there's not much needed from them.
Right.
So all we needed to do was how do we package the container itself? Should we run Unicode inside the container, outside, or should we run Nginx inside the container or not? That we had to do a lot of trial and error. That we can't decide.
We have shaped the Docker file and the entry point in such a way that it's generic across all.
So these microservices that you're talking about are written primarily in Rails, Python, and Go. You said
Rails.
Mostly Rails, Python. And so, how did you guys finally make the decision of where should Unicorn be and where should Nginx be? What does it look like now? What does a microservice container look like?
So basically, a container will hold Nginx and Unicorn
Inside.
So we did read upon like people who Dockerize Unicorn. Okay, it was highly recommended that you run Nginx inside the container itself. For it gives you added benefits like the request loggings and other.
And there is one
added. And then there is this added thing that gives you a benefit like Nginx may there is a level of caching that you get. So we are using that also. So we have cached inside the container itself.
Whereas the typical approach would have been to just have a simple Rails container which kind of like is the equivalent of running one worker and then having an API gateway that forwards to these these workers, right? So cool, interesting. So can you describe what this migration journey for you guys was like when you guys decided? Who was spearheading this movement of deciding to go all Docker? Was it like an internal revolution that started within the company, or was it somebody who came from the top and said, guys?
It was something internal.
It was something internal.
So when we ported API gateway to Docker, then we had
enough experience to.
Yeah.
Okay. So what is this API gateway component that you guys ported to Docker?
So the way any microservice talks to another service, or say any monolith talks to the microservice, is not direct interaction.
Okay.
So if you read this very famous GitHub article, so one of the principal pieces that he said was we need to have a SOA approach. So suppose that two teams sitting there, those two are not supposed to talk directly. There is no cross connection, nothing. You have a protocol set, just stick to that. So API gateway is that protocol. All I'll say is in your secrets when you're writing a microservice, don't come and give me some nice bribe about having your search and backdoors anywhere.
Got it.
No backdoors.
Everything goes to this.
Yeah. Everything, all the traffic has to go through gateway.
Okay.
Let the gateway handle routing and everything for you.
Okay.
We just talk to this.
So your gateway is like your logical single point of entry to
Yes.
this. And whenever there is service discovery or issues, your API gateway kind of handles that.
Yeah.
Right. So how do you prevent the API gateway from being a single point of failure? Is it because is the gateway itself replicated?
It's replicated across, and one of the very reasons which we choose Go was because for things which are very network intensive, right? This API gateway in itself is 13 MB of size, to give an idea. And it is so agile, and we don't even run it in a Ubuntu or Alpine Linux container.
You build
it
from
scratch.
Yeah, you build it
scratch binary.
with DF and whatever.
Yeah.
Correct.
OSHIPs and executable.
When your executable itself is that compact, then you don't have to worry about whether my API gateway is going to crash.
Yes. Cool. But now that you have an API gateway that is replicated, right?
Yeah.
Isn't the challenge going to be the configuration management for this API gateway?
Hard.
How do you guys handle
There
that?
is no, it does not write to disk. Okay, so
No, but by configuration management, I mean that if the API gateway is handling service discovery for you,
yeah.
suppose there's an update in the service discovery endpoint, right? The API gateway needs to reconfigure itself to be able to fetches from etc.
Yeah.
So it fetches from again on startup.
No. This is on the fly.
Okay, wonderful. So it refreshes from etcd.
So if it doesn't have its own in-memory cache, it goes and fetches from it.
Nice.
So just last week I broke the comma in etcd and the site was almost dying. And we had to fix it like now. Before everybody
Cool. So that was the first exercise that you guys internally took out. And then once you took that up, you guys said, okay, now we have sufficient experience with Docker. and we're managing all of these edge cases around how we would run this.
Yeah.
And so now we want to start dockerizing all the other microservices.
Yeah.
Right. Awesome. And was that a very smooth journey, or are there any particular horror stories that you can share?
So
The smooth journey is okay, but horror stories.
horror stories, there are some. So the whole, he had to play a lot with. First, he started out with only Rails, right?
Okay.
Then he started with Rails plus Unicorn, Rails plus Puma, Rails plus Passenger.
Right.
So
Right.
finding that right combination of
Yeah.
which application server to choose is drives both
That
performance and
Right.
resource utilization. That is the tough part.
And until fairly recently in the journey, we didn't have idea of bundling Nginx inside. Then we
The
realized,
caching there.
yeah,
Because if you move Nginx out of the equation, you need it somewhere else. You need to run it on Docker.
You have to run Nginx.
Yeah.
Ultimately, your Rails workers or
Yeah.
processes will have to be fronted by Nginx
Yeah.
at some point.
The other thing, like you can have Unicorn or anything written on the board as well, but then you lose that caching layer altogether. And there are also ways where you can rate limit. Like in cases of DDoS,
Correct.
which we have
Correct.
faced, rate limiting is very much required in that case. So we pushed Nginx also into that. So we also got to know about this one gem which people use called Profile. It's basically the gem which allows you to basically it will manage both the number of processes we do. So it will be watching both.
Right.
So in Docker, basically the process has to be running.
Right.
So in case of two processes which need to be running, you can use that gem. So it watches both.
So how did you benchmark this container? What was that process feel like? How did you set up the test bench to say this is a bad way of containerizing it, this is a good way of containerizing
so
it?
very simple fundamental. There should not be any performance hits. When I go Dockerize, I should not be going with the regression.
Right.
So for search, that was the first and the only.
So what you did first is you took the process by itself
Yeah.
and then you benchmark.
Yes.
What tool did you use to benchmark?
AB.
AB.
We did AB hammer of 1000, 5000, 10,000.
Correct.
See the networking latency there. Then initially when we ran Docker, we had some performance hits, right?
Yeah, it was good. That was because we had tried it without the caching layer.
Right.
So that was mainly Unicorn will blindly written on the code and then server. So that did.
So then you kept fine tuning this, running
Yeah.
the same AB benchmarks.
Yeah.
Cool. And that's very nice. And then after that first API gateway that you Dockerized how many more services?
Then we Dockerized Logstash.
Okay.
Was the next obvious
That was the
category.
next service.
And then
Then-
Tambor, image compression service.
So all the images that you see on UrbanLadder website are compressed. And this compression is done by Tambor. Tambor is Dockerized by himself, and there's this repo called APS of Tambor, where he has a nice hosted Docker file.
So in this time, the first time when you guys Dockerized, right? When you guys had to handle the sort of orchestration of these containers or the deployment of these containers, how were you guys? What was your first approach? Were you actually SSHing into your VMs and running Docker run commands or Docker compose commands or whatever fig commands as they used to be? Or when did you decide that you need something to kind of handle this for you? When did you start automating the rollouts of the containers themselves?
Our Docker journey was very hand in hand with ECS.
I see.
So we
Even
started
from the very beginning, you guys
Yeah.
started these.
Yeah.
So when ECS was a joke, then we had been with ECS, and at that time it was very bare bones, extremely bare bones,
Right.
in comparison.
Right.
Now, like almost like 6 to 8 months later, ECS is extremely competent.
Right.
So, for example, I'll give you one example. So if you're running something code dependent, right, and you want it to run on specific node, you have a cluster of 5 nodes, but you want that service to run only on one of the nodes.
Right.
In Kubernetes, it's very easy to do that. There are restrictions and
You can set up a label selector or definitely
Exactly.
use that node.
Right. That feature came in ECS like 2 weeks ago.
Ah.
Yeah, 2 to 3 weeks ago.
So what did you guys do then?
So if you want a container to run only on a particular host, you tie to the code of it. Like it has to have this code. You have to work around for that.
Right.
So even for there's one more hack for basically if you want multiple containers running on the same container, like same host, then probably so that is called dynamic code mapping in this case.
Right.
So you just give code 0 in ECS and then
Got
the essence of
For us, one advantage has been the time when ECS matured, Thus, when we Dockerize has been extremely amazing. Very handy man. So if you go back 6 months and if you check Google the ECS adoption, right, you will find 3 pages of rants against ECS. Why ECS is bad, why ECS is the next plague on earth, and you'll find all those articles. It's very easy to get distracted. But people will not say that if you are an AWS shop, which is very likely these days, very, very likely. True. So if you are going Kubernetes, fine. But keep in mind that Kubernetes is not a first-class citizen for Amazon, and vice versa as well. True. As far as I know, Kubernetes is not support ELBs till the slightly recent.
Till the last
ELB and then ALB. Right. So it's not really the first-class treatment. Even though community is very active, it may not get the greatest and best features.
True.
Okay,
so that way ECS worked out well for you.
And one more thing is that in Kubernetes you have to handle all the replication controllers, and of course you can't go to production with a single node for Kubernetes.
Mm-hmm.
So you have to think about your architecture for Kubernetes in the first place. This is an additional overhead. Even if I run Kubernetes in a very small T2 medium instance, that is a raw rate of $100 for me. So I'm paying extra just for orchestration.
I see.
ECS is free. He will handle all the orchestration by himself. You are only paying for EC2 workloads, which is actual business applications, right?
And the load balances you.
Yeah, I respect that, but although because I'm a Kubernetes fan, I would have rebuttals for that. But and I think the main rebuttal would be that the Kubernetes was optimized and was built to perform only one task, which was to make orchestration and deployments of containers easier. So the ease that will be there in using Kubernetes for a team will always be significantly higher than most alternatives for complicated use cases, right?
For
complicated use cases, it would. I mean, they're still fairly ahead of Docker Swarm themselves, right? Because Kubernetes is active. But that said, it always depends on where you can get Kubernetes running, right? So, for example, if you can't get Kubernetes running on AWS, right, then it absolutely doesn't make any sense to try to use it. Right? But I think Azure and GCP are both now they have deep integrations with Kubernetes, and especially Google's experience with Kubernetes is beyond amazing. It's absolutely. But I mean, I think it will gradually. It's still too much in flux. Right? There's too much stuff happening. Docker Swarm is also competing for this. Kubernetes is also competing for this. Amazon has their own ECS for this. Right? And then there is Mesos also, who suddenly decided that I'm going to go from infrastructure to application containers, right?
And Chef is coming into Docker.
And Chef is also now going to have So it's still going to be very, very messy. So So it really depends on comfort, right? Like for you guys, if AWS was very comfortable, instead of trying to learn something new, knowing that something is the first class in AWS, you guys get
when you are given an objective that you have to go Docker, but you don't have the luxury of time in these.
Exactly. You would choose the things that you're most familiar with, right, to get the job done. Completely. So now after this migration journey, right, what are the biggest expected benefits? You expected the benefit to happen and that happened, and what are the biggest unexpected benefits that you got out of moving to this?
Expected benefits, I would say, cost around 30 to 35% savings.
Right
off the bat.
Which was, I would classify that as unexpected.
That was expected.
That was expected. You guys were saying that one big part of this migration is to try to reduce it from 33 instances into 4. Cool. And obviously the developer problems of this is not working on my machine, all of those problems did get solved. So operationally things did become easier.
And shipping new services became very easy. So even today we can like shut shop and tell developers here you can do this, yes, you can do this. That's awesome. That's one thing.
And any unexpected benefits that you guys are in hindsight being like?
One of the unexpected benefits was networking performance on infrastructure. So,
but that's an AWS thing more than a problem.
So any cloud platform you go for. So even the networking performance is usually bigger the better. The bigger node you take, the better network interface you get. And that goes true across any of these things.
Correct.
Any of the cloud products.
But so GCP and Azure usually document it. So they document that.
Even this is documented.
Oh, okay.
So see, that is I would say lack of flexibility on all these cloud providers.
Right.
So suppose you want one core, or still it's 2 cores.
But I
want a lot of RAM. I want amazing network. Nobody will give you that.
Right.
Right?
GCP is trying to, right? They are trying to give you these custom built nodes.
Yeah.
I don't know.
We were also contacted by Chennai based.
I don't. Yeah, but I don't know. Chennai based cloud providers also need this, right? But I don't know if they allow you to tweak your IOPS and your network.
They do.
If
Like
they
you can
allow
add
you.
it on top of it.
Right.
That is fine. But again, as we were discussing offline, so one of these cases are you know that your services are not going to take up more than 20% of CPU time at any given time. Unless it's terrible code, your CPU utilization will be 5 to 10% tops. Now the problem is you can't just downsize and start T2 micros and say, boss, आपका service launch हो गया and you're done. Because then your network performance will be terrible. You'll start losing bits.
Correct.
So you'll have to strike a balance between, somewhere acceptable performance and cost. So this is one of the reasons we went from CX series. So if you are a familiar AWS person, you know that CE series is starting for something compute intensive performance.
Right.
So it gives good networking performance and especially optimized compute performance.
Right.
It double the cost basically.
Right.
So that went from that to normal M4 general purpose computing.
Right.
So there you get like half the cost, but like very significantly lower price and same networking performance.
Right.
That was a sweet spot, and because we went out from burst instances, I'm not sure what's a burst instance equivalent in
In
GCP. So because we hosted all the microservices on burst instances,
Right.
we went from there to AWS M4.Slash and we got like better upgrade in network performance.
Right.
That was
Right.
fairly unexpected also.
And so whenever you guys are trying to choose what is the right kind of box to have underneath, right, underneath your services, was this like a scientific thing, or was this kind of like by trial and error? You tried this, you ran A/B again, a bunch of them.
No, it's basically calculated. So we know how much we consume, and we know how much it provides. So it's math.
So then you work it out.
Yeah.
Okay, smart. So I guess I have a bunch of closing questions, right? So what after having done this journey, right? What does Docker mean to you? Like, what do you guys, if you guys had to explain what Docker does, right? What does Docker mean to you? And with the fact that today Docker is a lot more complicated than what Docker was a few months ago, where it was just a runtime. But now Docker also means the kind of engine, it also means the compose engine, it also means the swarm engine. So there's different parts of it. Right? So now if you had to explain Docker to somebody or to yourself, what would you say Docker was?
So you will say 2 words that Docker is an orchestration killer.
Okay.
For a fair reason. So suppose Vachan is a developer. He's developing a
Suppose.
Yeah. Let's take it down from your title. Get the option.
Okay.
So he's developing something, and then he'll come to me and say, boss, now I have to deploy this. Now traditionally the flow goes something like I will spend a day probably writing orchestration scripts on it.
Okay.
Or if I have templates, I have to pick that template and then make accommodations for this. Then I'll have to launch it. Now what he can instead do is all he has to do is write one startup script, his entry point script,
Right.
along with his service. Then he can say, boss, here आपका container, ये आपका entry point, then launch it wherever you want.
And it worked.
Yeah.
So it kills the need for having orchestration tools.
Yeah.
If you have orchestration complexity, you should use Docker.
Unless you have very specific use case for something like Chef.
Cool. So for you, Docker is to reduce orchestration complexity, right? But what about the other benefits of Docker? What about benefits of Docker, for example, when you guys are doing your DevOps tooling, or when you guys are doing say local development and your, like you said, right, initial setup is too complicated. Would you be a strong advocate for Docker for that as well? Is that like that is what you should definitely use Docker for, or is that is something that you put in the category of it's good to use Docker, but it's not necessary? Whereas in the orchestration world, you would be like, I think it's almost necessary to use Docker.
But that is again relative to your setup.
I mean, I'm talking about how you guys think.
For our uses, of course, it is a must.
So
Docker
if
is a
we
must for that.
Okay.
if we tell a local developer to use Docker on his first onboarding day, then we are winning there. Because then he will have 15 applications on his laptop. He'll have to mangle with all the dependencies.
Got it.
Say Docker 2x is needed for something,
Right.
and Docker 1x is needed for something else.
Right.
then you'll have to start playing with RVMs and you'll have to make this header unnecessary things. Instead, you can just go to container, write the application code and be done. That's it.
So that's the thing, right? So you will now, so we have even Dockerized the DAM for us, like digital asset management service. So if someone is doing a local development on that, we can just ship him the image, he runs it, it is local and then
as a local, as a person who's doing development locally on my machine, right? Do you guys have a policy inside the organization that tells people that here are these Docker containers? These Docker containers are installed with all the right dependencies, with the right runtime, and all you should do is kind of mount your code as a data volume, mount your code as a volume inside this container, and then use that to run local development? Or is that something that developers are doing inside the organization? Or is it still like, no, I'll get my own rate set up, so if I was in Python, I'm using virtual env. If I'm using Node.js, then I'll use something like N or NPM along with NPM, it should be fine. What is it right now like for you guys?
So there is one inertia among developers that if they have a setup ongoing, right, they don't have a major inclination to switch setup and put out switching it.
Correct.
So most of our developers already have something set up and it works for them.
Okay. And at the end of it, you told them add this Docker file, run it.
Yes.
And that's enough.
For them, I'll tell that we have a Docker file committed in your repo. Don't touch it.
Don't touch it, just let it be.
Yeah, let it be. Do your development and commit it. And we'll take care of the rest. Because for somebody to know developmental setup, right, it's a cost and time overhead for us. Right. Which we don't want to do it, basically, as well as that. If it works for them, fine. As long as the code changes up, features are being churned out, it doesn't matter really.
So that brings us to an interesting question, right? So how are you guys kind of discovering the boundary between the dev team and the DevOps team, right? So now that you guys have kind of this experience of migration and whatnot, if you were to go and talk to another organization and say, think of these as your developers, think of these as your DevOps guys. How do you, what principles will you tell them? What will you say that, okay, get your devs to do this, don't worry about this part, not worth it, get your DevOps guys to do this, get them familiar with this. How would you draw that boundary? What are the processes that you will set up?
So, UrbanLadder as a whole, I mean, fairly recently, at least we started believing that DevOps is not a team. I mean, sorry for hurting all the kittens here, but DevOps as a team should be, it's not the right term.
Right.
You may call it system engineers, right, which is a better term I would say. Because you have expertise in Linux, you have expertise in writing system code.
Or in the infrastructure.
Right. Infra guys is also a better term than DevOps team.
Right.
Then you assume that, with the title itself, you are assuming that they do development plus operations. Which might be true only to infra toolkit or infra environments, right? But it should come to the point that we need to go on a vacation, right? Or we die in some plane crash or whatever. But the org should not go. Yeah.
Not only did you become a developer today, but you also died today. Many things happen. Eventful after.
So basically, if that happens, nobody should be impacted, and the workflow should keep going on.
So you're saying that DevOps is not really a team. It's more like a culture or a process that you enforce, and it's something that is very developer driven also. That you have to give to the developers to do, and there is or whatever your team or your DevOps work is to kind of automate that flow from development to final outcome.
Okay, I think most of you guys have seen this Netflix talk, A Day in Life of DevOps Engineer in Netflix.
Right.
And where he boasts about having 10 DevOps engineers in Netflix.
Correct.
So if Netflix can run their shop in with 10 DevOps engineers, then sure as hell we can do without any. That's a simple logic, but you know how it goes.
Okay? Makes sense. So we talked about what benefits of Docker are when you tell people to use Docker, right? So you tell people to use Docker when they have an orchestration problem. You'll tell people to use Docker to say if your initial ramp-up time is very high, use Docker and tell it. When will you tell people to not use Docker? When will you say, guys, don't think about Docker, it doesn't make sense, or does that never happen? You like so always use Docker.
With Sumesh, I had this conversation like I said last week, so this was like, bro, I need to Dockerize Elasticsearch. I'm like, okay, why?
There are things that need to be scaled vertically.
Yeah.
So for example, when it comes to Elasticsearch and all, there are times when you need to scale it, the heap, you have to increase the heap size. So for those things, Docker doesn't really make sense.
So
but doesn't add too much value.
Yeah, doesn't add too much value.
So we have very simple product. Like we will have monoliths, like last of the chain. First will be a microservice of nimble little code services, right? They will be the highest priority. Or even better, if your org shifts binaries, then awesome, give me binaries. I'll run it on Docker.
Right.
Then will come your microservices. Then maybe if your monolith is well enough, I'll run your monolith in Docker. Last comes your data stores.
And then when you're daring, you must go to data.
Exactly.
Because there are like horror stories where people don't mount the data containers out of
All kinds of
places, and then the container restarts and boom.
But that's a very nice gradation, right? So you start off with like these binary type services, then you go to dynamic language type services which have runtimes, then you go to monoliths, and then finally, if required, you go to data stores.
So actually, we had tried out, like we had tried Dockerizing Mongo. Like we did have a working solution, but then when it comes to clustering, there are a lot of things that Mongo clustering itself needs to be, like there are commands which you
Correct.
run. So there it becomes very tricky. Like Dockerizing.
So basically, Vachan should not do black magic to get a
Yeah.
Docker
It
container.
should be like something I know, and if I'm not there,
Nobody can run it. Yes, got it. So stateless, Dockerizing stateless applications and preferably not monolithic applications is kind of the sweet spot for you.
Yeah.
Okay, cool. Alright, awesome. So I think I'm done with the set of questions that I have for you guys. Alright, thanks so much guys. Good chat.
thank you.
Yes.